Okay, just to set you up for what you're about to see, I am claiming that we created muon and electron neutrinos and then split them into the muons and electron showers. And here's the electron showers, the white bit, and here is the muons, the black bit. The black bit came in along with the white bit attached together in virtually just like this. Alright, the black and the white. Whoops, just like that. And when hit another medium, which is Cherenkov radiation, the white one exploded into the showers, and the black one just sort of got out of the way. Now, we created a special device that forces this to happen. They, at CERN and everywhere else, Fermilab, they're looking for it to happen by accident. We can make it happen on demand. That is a game changer. We took red laser light and accelerated. That's a game changer. Not supposed to happen. Not allowed, according to the standard model. This is the 2p2h particle that they've been looking for many years. Two black pits are the 2h's, the holes. 2p's are the particles. 2p2h. Look it up, Cornell University. And they said you can do this, you can get excess energy, which means free energy. These are the Higgs fields, they're all over the place. This is a particle nobody's ever seen before, and I've only seen one of them, and I think it was from a reverse spinner. That's a whole other issue. You're supposed to have the right-hand rule where everything spins to the right. Now, the green is identical to the red, only much more energetic, but the same 2p2h particle, which is, they're nothing but photons. And this is exactly what CERN wanted to see, was this event, which it is captured right there. And one last thing before we go forward is the actual charging of the neutrinos. These, with this, they call this the electron neutrino, and they call that the muon neutrino. Back to back, together, they make a photon. That will bounce off of you and create light. That's how we get light. Now, why does it bounce? Well, what it's doing is it's hitting, in front of it here is all the electrons and the gases in the air. And if this was a solid wall, it would hit it and bounce off, because it's not going to incorporate like electricity will. Electricity is a single one of these. That's lightning, static, electric. It wants to incorporate at least into one more of them. And that's why electricity will jump right off you to ground and try to get into ground, which is this dark matter. Now, that's another issue we'll talk about later. But this is the charging of the muon, the electron neutrino. And this is the discharged one, which is here. And the dark matter never changes. And you can see the glowy particles this is bumping in against. And that'll charge up, and then it will wobble. It'll go bloop and go to the back. This one will go bloop and go to the front. And then it'll start to absorb energy just like this. It'll be concussing up here. So that's the cause the muon wobble. Now, let's go forward and see if we can make some understanding of all this. Because if we can use this energy right now, I'm going to tell you right now, free energy is at the doorstep. Alright, before we get started, I want you to know, nobody understands quantum physics at all. This is Yale University. I went to University of Geneva for particle physics. And Yale, they understand they don't know. They know they don't know. That's the key. And to refuse to engage in seeing something that actually is evidence is upsetting. But listen to what he has to say. This is Yale University. And again, you can go for free. I don't have any papers from them to say, oh yeah, you went to Yale and you can repeat what I told you to say. And that's all he's saying. Repeat what I told you to say, and that's the best we can do. And he actually says it. Listen.
So this is a very exciting day for me, because today we're going to start quantum mechanics, and that's all we'll do till the end of the term. Now, I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively, and the good news is that nobody can follow it intuitively. Richard Feynman, one of the big figures in physics, used to say no one understands quantum mechanics. So in some sense the pressure is off for you guys, because I don't get it and you don't get it and Feynman doesn't get it. The point is, here's my goal. Right now, I am the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics. Then you can go back and spread your ignorance everywhere else. That's the only legacy a teacher can want. So,
You know, I got to tell you something. This is the only honest guy I've found as a teacher. And I am very impressed that he doesn't have doodles all over the back of his board. Because every time you see these guys, all they got is doodle-looking things. When I was writing these doodles, I was a moron. All I was trying to do was impress the professors with, oh yeah, I can make this all work out. I can draw all kind of doodles. Nobody knew what they meant. They didn't know what their own doodles meant. These people have no clue. And just like he said, they don't understand. I think I understand because I did the experiments. And I worked on this stuff for 50 years. You know, I was in nuclear missiles when I was in the Army, and then after that I got into physics, and then I started my own business of electronics. And I went into that because physics expelled me, because I said there is no such thing as one gigantic positive core. It's impossible. Absolutely impossible. And they, oh, no, you got to listen to Bohr theory and all this. Well, it didn't work out for me because I didn't want to just go spread ignorance. Okay, it's well understood now the Bohr model cannot explain virtually anything. And the reason is that they have one gigantic positive in the center and then a bunch of little negatives floating around. It would be impossible. They'd just snap right in and attach. I've known this for 50 years, and that's why I got out of physics, because they just would not listen to me. I mean, no matter what I presented, it was like against the wall. So I said, that's it for them. Anyway, my nucleus is this. And my electrons are the same as the particles that are in the nucleus, only they have enough of them in the nucleus they don't want anymore. So this one comes in, he says, I really want to get to that dark matter, which is deep inside the nucleus. And it says, you can't come here. We have plenty of electrons already. We don't need any more. And then it makes it stay in a distance away. And a hydrogen would be enough electrons here that it would still want to collect one more, all right, hydrogen 1, and it would say, no, you can't get here, stay that far away and we're okay. That's quantum. All right, but you would never have a big positive center. So this is all wrong. Bohr is wrong, completely wrong. And remember I told you there's 2 electrons in the center? You can have only, like, they could have actually 4. They're showing 2 right next to each other. That's not going to be correct. There's going to be 1 here and 1 over here. And if there was 4, there'd be 1, 1, 1, and 1. Because they want to stay apart from each other as far as they can, the white ones. They don't want to touch each other, ever. They will separate each other as far as they can away. And that creates dark areas, because they push all the darkness into the center and surround it with the white, because the white wants to get away from each other. So it creates a surrounding encasement of the black matter. Okay, so they say the nucleus is one big gigantic ball in the center, positive, and then these little electrons. Well, I say no, the nucleus is a ton of electrons. Well, what is my electron like? Is my electron just negative? That can't be. And it isn't. They're negative and positive. And here are the electrons, right there. 1 here and 1 here. Back to back, 2 bar magnets. That's all they are, is little tiny bar magnets. Now, the only time they will show in this configuration is just before they explode at the Venturi. And here's how this all happens. Don't forget, now you have a black ball attached to a white ball. Let me just show you what my electron flood model is first. It's a dipole, first of all. Electrons are not just negative. They're not just negative. They do have a negative explosive side, which is what we consider electricity, lightning, static. It's the electrons that we always thought were the cloud that surrounded the nucleus. No, the nucleus is just a ball of these electrons. And then, yes, there's a cloud of them more that want to get into that dark matter, because the dark matter is so attractive that it wants more electrons. It'll take more if they would get through. And sometimes you do get a couple extra coming in there, and that's called, you know, an isotope. It's not really exactly the right number of electrons in the core. It has extras or not enough. It's a charged particle. They understand all this. They just don't understand. They can never have seen what we saw because of Rod's experiments. He created this Venturi. It was absolute accident. He's not an atomic guy. He has nothing to do with atomics. I'm doing the atomic side. He created this Venturi absolutely by accident, and it was so elegant. And then we worked together for years to try to understand all this. You know, I did. Basically, he kept doing the experiments. I asked him, please try this, and he did. Absolutely unbelievable how much work he put into this. And he's still doing it today, as I am. So he accelerated light. Just this one palette of pictures completely changes everything there is about physics in the energy realm and light. And you say, well, show me. Well, first of all, let's take light itself. That is a wave. These are waves of red pulsed laser. Poof, 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 coming out of a little tiny laser just like this. Now, because they're particles, as I just showed you, and they have an explosive side, everything else that's in the world or in the universe is made out of electrons. There is nothing that isn't made out of electrons. So what does that say? That says that we have an explosive side to everything there is, and we have that dark matter which wants to pull everything in together. So when we excite this, we're going to get a glow. It's push to shove. Remember PTS, push to shove. If I push on another electron, which everything there is has electrons, so whatever I push against another thing, it's going to create a little tiny bit of heat. Depends on how hard I hit it. If I hit it harder than hell, boom, there's a ton of heat. If I just barely touch it, there's still going to be some kind of interaction. There's going to be a glow. And here's the glow of light coming through the air. We're picking up right at the very front of the light particle. And the particle is there, and remember, don't forget, the particle is right there. That's what the particle is. You're never going to see that. You don't see it up here at all. You don't see any particle. There's no particle. There's glow, and that glow is there because it's bumping into everything that was in the air. Because everything that's in the air is a gas. And all gases are made out of molecules. And all molecules are made out of atoms. And all atoms are made out of electrons. So it's going to be push to shove of this really powerful banger hitting against all the electrons that are out there. They just have to get out of the way. So you push to shove, they glow a little bit, and that one glows like crazy because it's coming through the air. Now, it is slowing down as it's hitting these. There's no question about that. However, if you put in a Venturi, that wave will force the particle to expel itself right from the wave and accelerate like a rocket ship and then explode here because it cannot get through the Venturi in totality. You say, well, what does that mean, Roger? Well, it means only the white is allowed to come through this Venturi if it is tuned correctly, which means what is the size of the Venturi? How is it constructed? If it's tuned correctly, only the white particle of these attached particles here, the white will actually literally separate from its charged partner, which I thought was just impossible, but it's obviously done because we're seeing them back to back, and we're seeing them up here. That was this stream. And of that, there is no question. I can show you it manifesting itself. Absolutely no question. Green does the same thing. Blue does the same thing. And at the Venturi, they literally separate the black portion from the white. That means fission. Fission means to divide something. It means to fission. Fission means cutting something apart. We have cut apart the photon and broken it into its component parts, which is a muon, the black ball. All right, that'll be the muon. and that is going to be the electron shower. Right now it's an electron neutrino. Until it turns concussive and showers, they call it a neutrino. After the shower starts, it's called an electron shower. And I'll show you that in a second. And these are the electron showers. And back here was the particle just as it was starting to explode. And back here it would be called an electron neutrino. When it comes back together out here, the black particle reattaches. You know, there must be other black particles just laying around here, because I don't think these ones jumped out of here and jumped to attach. No. But here's how they do separate, and here's how they do attach. And here's what this is. This is cold nuclear fusion. Cold fusion on a desktop, changing from this energy level to literally an atomic explosion. Because this is fission. This is fusion. It's an atomic explosion. This is energy on steroids. Approximately, they say, 207 times more energetic than this particle. I don't know if that's true, but it certainly looks like it is. Now, let's see what happens at the fission and at the fusion. All right, remember coming in, they were in a little configuration of 4 little balls, 2 black ones and 2 white ones. The black ones have separated from the white. This is 100% pure, unadulterated whiteness. The black balls have gone around the edges, and they come right here. At this exact point, they start to reintegrate with the white particle, which has been separated from it. So this was the fission. Fission means to separate. Fission. At this point, it's raw energy, and then it comes back together. That's called fusion. This is nuclear because it's in the subatomic range. Fission, fusion, that's nuclear energy on a desktop. Cold, room temperature, fusion. Totally unexpected. Right now they're using millions of degrees of temperature, so they're taking all the heat and they're forcing particles to divide, and then when they come back together they're recouping what energy is left, and it's only up to 80% now, so they're losing 20% and they're happy. I'm showing you energy increase with no additional input whatsoever. This is a passive device, simply a tuned Venturi. Once you build it, the case is closed. This laser comes in, the energy is manifested enormous. And right now, nobody understands this. Nobody has done anything with this. It's been shown for 6 years. There should be no patent rights available to anyone, so anyone should be able to do this and make money making devices. You're going to have to act now, get them made, make the cheapest one you can make, like a Model T, a laser, a Venturi, a solar cell. Collect it and pump it into whatever you want, and you got free energy. You can walk around it with your hand. There's no grid required. You can create any voltage and wattage you want using this. If it works the way I'm expecting it will work. We have seen an extreme increase in energy. That's fission, that's fusion. That's exactly what they're trying to do right now, everywhere in the world. And we did it. So I think this should be utilized. All right, you see this? I've been talking about this for a long time. Nuclear fusion is exactly what I just showed you. Nuclear fusion could rescue the planet from climate catastrophe. Nuclear fusion could be the clean energy that the world needs, and private companies are now working on machines to harness it. Well, let's talk to me. They're talking about 12 private companies around the world are working to harness transformative energy technology could rescue the planet from climate catastrophe. Well, they're going about it in the wrong way. You see what they're doing? They're spending billions of dollars to create all this high energy, and all they're doing is putting energy in and getting back a portion of it. And that's as best they can do. Fusion is not working. But it is the perfect way to make energy, except for one thing: we don't know how to do it. So this is quick table nuclear fusion. In fission, a large unstable nucleus is split. No, in our fission, It's the photons that split. That's why we're in good shape. They're trying to split gigantic chunks, and when you do, then you're in trouble, because if they get out of control, they're throwing out hand grenades. We're just shooting out photons. They're not going to hurt you. It's cold fusion. Anyway, this is going to get complicated, and we're going to be talking about nucleuses and, you know, energy levels and all that. But trust me, fusion is the way to go. They just don't know how to do it. Exactly what he said. And they still don't know how to do it. But look what they're trying to do. These are the kind of things they're using. Think about this. You know, that's nice. It's wonderful they're working hard at this. But to ignore what I've been showing for 6 years because they want to develop something that takes a lot of money and they can get a lot of jobs out of it, well, maybe that's good. Maybe it is. I don't know. But you don't need deuterium. You don't need heavy hydrogens. You don't need all of these kind of things that they have to spend a ton of money to do and build all of these crazy, complicated devices strictly to break things and then let them come back together and just recoup whatever you can get back. And like I say, it's only 80% now. So it's time to look at this in a much different way. Look at this. Fusion's promise is huge. It would be the most energy-dense form of power. I showed you density of energy that was just incredible from a tiny laser. A liter of fusion fuel is equivalent to 55,000 barrels of oil in its most common form. That fuel would come from a practically inexhaustible source, water. Well, we have an inexhaustible source, electrons. And that's all they are, is electrons. They're light. So we don't have to do anything other than send that laser out. And we don't have to get them out of hydrogen and then break them down and make deuterium and tritium and all these fancy little molecules. No, we just turn it on. Okay, this is from the U.S. Department of Energy, who has me blocked from commenting on anything. And they're talking about fission versus fusion. Let's see what we have here. Physical processes that produce energy. All right, so boom. We split a larger atom into two or more smaller pieces. We split photons. That's the problem. They don't understand that we can get down to the level we're at. So they're trying to split huge pieces, and that's dangerous. All right, so they split them into smaller ones. Now, what happens in fusion? They join two or more lighter atoms into a larger one. Well, we join and back our light particles into the light. So the smaller the muon and the electron shower comes back into light. Exactly like joining two chunks together, which are the atoms. When we do that, we get a ton of energy. As you could see, it was brighter, exploded. So join two or more lighter atoms into a larger one, which is we joined two or more photons into photons. Now they're using, look, uranium, plutonium, this is all very dangerous stuff. Fusion uses hydrogen. I agree, because hydrogen is basically what electrons are, is in the hydrogen range. They're the smallest little particles there is. So here's the byproducts. They're going to be nuclear fuel, or use fission, because they're just gigantic particles. Helium is the product of fusing hydrogen. Now, we're just going to have light. We're not even going to get to the helium stage. All we're going to do is take light apart and put it back together. And when we took it apart, we didn't have to do anything whatsoever, and it came back together all by itself. Look at 1 million times greater than other energy sources. 3 to 4 times greater than fission. So not only are we doing fission on the left side, we're doing fusion on the right side. All right? I don't understand why they won't allow me to talk about this. Clean, reliable nuclear. Exactly. It's exactly what I showed. All right, Nikola Tesla. Its energy is frequency and vibration. Now, this is by Bruspup. This is a salt table. A frequency table. And what they're doing is they're sending in, virtually pulsating that table. And what does that? That makes your electrons, because it's all coated with electrons, push to shove. Now, salt is extremely polar. NaCl, both sides of the periodic chart. They're going to vibrate that metal plate. So all they're pushing and shoving electrons. and then you will see these patterns form. And at a very, very low frequency, you're going to see what appears to me to be hydrogen or helium, which is up here on the periodic table. H and helium, hydrogen and helium. And they only have one very small orbital surrounding the nucleus. And it can have up to 4 electrons in it. I mean, that's what it looks like to me. That's exactly what we're looking at. Now, then you get into what's called the rule of 8. And the rule of 8 means there can be 8 surrounding electrons around the core. Now watch what happens as they increase the frequency. That's 345. Now they're going to shake it a little harder, and all of a sudden you're going to see that pattern of 8 show up there. That's called the rule of 8. So now you have a nucleus, and then you have the 8 electrons, 8 electrons surrounding it. All I can say is this, it looks just like exactly what I'm expecting to see, because that would be starting into your rule of 8 electrons. And then you get way up here to where they get really exotic. You know, but you still have this pattern of surrounding. It's push to shove. So they're pushing, shoving, pushing, and then all of a sudden they get to a point where everybody's pushing and shoving exactly in a nice way, and they say, okay, I'm okay with that, boop, and they lock in. But then you increase the frequency, and then another guy over here says, all of a sudden it just falls apart. Watch. There it is, nice, and it's a nice, look at the patterns, absolutely amazing. But as soon as they change the frequency, it gets all buzzy again. See? You know, they're changing it and locking it in quickly. But in between, it's just 100% buzz. And I can show you that, and I will. And let's do playback speed 25%. Let's go back here to just a hair back, and let's see what happens as it slowly makes its change. See it? They're starting to fight each other. They're fighting. And so all of a sudden they say, well, everybody is going to get comfortable at a point, and they're going to lock in, and they'll sort of make these nice patterns now. And then when they change, see how nicely they're locking in? And then, but see it bouncing around? They want to either be, and then all of a sudden they'll lock into a nice, consistent pattern. And then you increase the frequency. Look what happens. You see it? Everybody's bouncing around, and all of a sudden they'll push and shove and push and shove and push and shove, and boom, they'll lock in. This is what this whole thing is about right here. Because the bigger they get, the bigger they get. I mean, that's all it is. The more little patterns you get, until you get to a point where there's so many patterns that they don't hold on to each other anymore. And that's up around, you know, way up in the upper ranges. They're just not stable, really, because there's just too many of them all hanging onto one big ball. Stability comes down in this area down in here. These are very stable molecules or atoms, but they have extra little pieces hanging off. So they might have a piece hanging off like this, and it wants to attach to another. You know, I mean, it won't look like that, but think of it this way. Another one comes along, and it wants to have a piece like that attached to it. So it grabs on, and they become a package. And then you have a molecule. One of them might be tiny, an atom down here, hydrogen, and it might be hooked up with something else, like oxygen, H2O. So there's 2 H's and an O. And they hang off the side like this, with 2 ears. That's just all it is, because it has an extra electron. It says, hey, will you share one with me? I say, yeah, sure, no problem. It says, but you got to bring a buddy along, because I got another extra one. So now you're going to have 2 ears hanging off. And it makes a shape something like that. That's all these things are, is little attachments to other attachments. All right, these are tractor beam magnets, and this is identical to what an atom nucleus is, and this is what would be an electron. The electron wants to get in to the core, because the core is dark matter. It's the attractive gravity part, but it is surrounded by white electrons. I'm going to call these white and dark electrons, because that's what they are. An electron has 2 pieces. It has a dark matter and it has a white matter. And it pushes the dark matters to the center and surrounded by these white matters. which is the explosive, concussive, reactive, radiation, glowy part that we can see. It's the electrical part. It's the static. It's electricity. It's lightning. It's light. It bounces. Inside is the dark matter, which is the attractor, and that is the attractor. This will only be allowed to get a certain distance away because these guys completely surround the core. There's no extra room for this guy to get in there. He says, no, we're all set. We got just enough guys surrounding the core, so you got to stay away. And he said, no, I want to come in. I said, no, you can't. You can stay over here. That's okay, but you cannot come past us because we are holding on to that dark core. And here it is in action. Watch. And he's going to bring this thing up next to it. Boom, there it is. Now, when he shakes it around, it'll stay there because that's the nature of a atom, of a molecule too. They're stable-ish. Now, you can heat them up and they'll shake around and buzz like I showed you before. All that is extra frequencies, extra heat. And he's creating heat. That's heat. Now, once that thing takes off, it's light. Boom, it took off. That's light. Watch, he'll shake it around again. Here he goes. Boom, 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 boom. That's heat. You don't see that. Boom. That's what you see as light. When that comes out, it hits your eyeball. What does it do to your eyeball? Why does your eyeball see that? Why would your eyeball see an electron going flying out at it? Well, let's see if we can figure that out. Okay, my outstanding friends, I am going to have a good time with this today. If you want to understand electronics and how everything works, basically because everything is electricity, 100% of everything is electrons, which attach to other electrons, which creates sprites, lightning, electricity, molecules, heat, cold. 100% of everything is electrons interacting with other electrons. And I call it push to shove, PTS. Now, in order for me to explain my electron flood theory, which says there is nothing but electrons, I have to explain every single type of electrical interaction, 100%. I don't care what it is. And I'm going to do that today as much as I can find that is unexplained, like sprites, how your eyes work, how your eyes transfer colors and all that information to your brain. How does it pick it up? Well, they're rods and cones, but how do they work? We're going to talk about that. We're going to talk about sprites. We're going to talk about aurora borealis, the northern lights. We're going to talk about lightning and storms and thunderstorms and hurricanes and the global interaction of the weather. That's all push to shove. If you don't understand electron flood theory, you're never, ever, 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 ever going to understand what's going on with anything, virtually anything. Everything is based on electrons only, and that's the only thing that exists. So instead of having one electron and one gigantic proton for hydrogen, you have one little electron, but then the nucleus, which normally we thought was one proton, is actually 1,839 other little electrons. They just glob together in these what we call resonance frequency stable quantities. And there's a certain hum that buzzes them around because they're magnetic and they're bouncing back and forth, and boop, and all of a sudden they lock in. I cannot totally explain that. I really cannot. But I can see it. I can show it to you. Very simple to show it to you. It's just salt table experiment. Salt is an extremely polar molecule, and they vibrate a plate, which is nothing more than push it to shove the electrons on the plate, and it pushes and shoves the electrons in the salt, and they make these elegant patterns that exactly represent to me what a molecule would look like, or an atom would look like. So there is. Well, let me show it to you because you're never going to understand it until I show you. So I have to show you every one of these little things. So if you're interested, stick around. If you're not, vayos con Dios, amigo. Okay, so how do we see? How do we see light? How do we see these different colors? And how do we see the intensities? Well, let's talk about, this is a video by Carrie Kim. And this is about phototransduction, how we see photons. How do we see them? And this is a pretty good video. And again, phototransduction, how we see photons, Carrie Kim. Now listen to this carefully, and I'm going to try to explain my explanation of push to shove, which is what's happening in these rods. There's little pads, boom, 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 and the harder it hits, the push or shove, or push and shove back and forth until it just dissipates its energy. And at that point, we know the intensity. And so here it goes.
Is the process by which light is converted into electrical signals in photoreceptors. There are two types of photoreceptors.
All right, there's two types. Now, one of them, well, let him talk, and then I'll try to explain. So there's two types. There's the rods, and then there's the cones.
In this video, we'll be focusing on the rods. A similar process occurs in cones, but they are less sensitive to individual photons, requiring much brighter light.
All right, so these require much brighter light because you're going to see what he's going to show. There's like all these little cells in here. So it's push, bounce, push, bounce, boom, 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 and it's push to shove, push to shove, push to shove, push to shove, and it stops here. Then you know that's a certain color or intensity. I'm not exactly sure, but I believe it would probably be the intensity because it's how hard it's hitting. This will tell you what the color is.
The light-sensitive region of the rod is here, where inside there are numerous disc-shaped structures stacked atop of each other.
All right, you see these? Push to shove, push to shove, push to shove, push to shove, push to, and then it stops. Now, if it's really intense, and by the time it gets to the bottom, you know, I say, whoa, that was serious. Now, if that was just a coil like this, when that little particle hit the end, the whole thing would compress, you see, as a unit. This, everyone's separate, so it goes push, 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 push. So at a certain point, it runs out of push to shove, and that's how you know the intensity of the light that hits you. The disc membranes that contain millions.
These discs are membranes that contain millions of light-sensing molecules called rhodopsin.
All right, when they say light sensing, what is light sensing? Light senses an electrical impact. That's what light is. Light is electrical impact. So that's all. That closes the case as far as I'm concerned. The light activates this rhodospin, which is some kind of enzyme or whatever it is. It's a molecule that somehow transfers that information at that level of the rod to the brain. Now that I can't explain, but I can understand the activity and the interaction and the absorption of the energy and how it would get to a certain point and say, okay, that's a point, I just received a certain level of light. And it would match it up to the cone, and the cone would say, yeah, that was blue, or whatever it was. All right, now pay attention carefully. This is a little confusing. It's not too bad. Every one of those discs is loaded with these little molecules. All right, now they're called rhodopsin, and it has two parts. I'm going to let him explain it. But what's going to happen is if you can have enough energy to push an electron into this, it reorganizes and sends out a signal. So at some point, you're not going to have enough energy, and that's the end of the... you're at that level of intensity. Now listen to what he has to say here.
Molecule called retinal attached to a protein called opsin. When light is absorbed, it results in...
Light being absorbed means you have an electron pushing and shoving, and that electron is being allowed to be absorbed. It has enough impact to allow it to absorb it into it. It's like shooting a BB against something and it bounces off. It just didn't have enough energy, and at that point it's all over. But if it's BB's hard enough, it'll push in and it'll change that, and then it'll just keep going down and hit another one and change that until it just doesn't have enough energy. And that's what's happening here.
In a rearrangement of a double bond in the middle to change it from this to this.
That's because when it takes in the electron.
This tiny rearrangement of retinal pushes on parts of the rhodopsin, activating it.
pushes on parts, pushes on. So everything is push to shove. It activates it. At that point, it pushes an electron somewhere into this neural network that is all your nerves. And somehow your brain calculates this is 27 disks down. That means we just got 2 lumens of light, and match it up to the rod, and it says it was blue light or whatever. It's very, very amazing.
The challenge is this. This activated rhodopsin must produce a signal large enough to affect the whole cell.
All right. So anyway, they're talking about amplifying a signal, all that. I'm at the point where I think I can understand how it's, because everything's push to shove. Once you take push to shove and electron flood theory, then you can begin to understand things. Because before that, everything is just a guess. There's no real structure under anything. Do you realize how many things are totally not understood? Hold on a second. Look at this. These are current unknowns. They don't know even whether light is a particle or a wave. No idea. Gravity, you drop something to the floor, no idea why force falls to the floor. None of the models work. Matter, dark versus reflective. They have no, they're all talking about dark matter. Oh, there gotta be dark matter everywhere else. 85% is dark matter. Well, I can show it. Light speed, no, absolutely. I can accelerate light, no question whatsoever, with the device Rod Warren made, a little Venturi. I could show that, and I have 1,000,000 times. Space is not a vacuum. It's filled with electrons, which are the light, and the particles, which I also show. And this is the electron flood theory. And that is my email if someone would like to engage, somebody. I need somebody important to talk about this, to get this understood in the physics arena, because it's just not understood. And I'm going to just continue on showing you today a ton of evidence to support exactly what I'm saying. Everything is electrons, everything is push to shove, and electrons are dipoles. Well, actually, what we're going to do is just continue on day after day. I'm just going to continue to just go over and over this. So if you don't like to see it over and over, go somewhere else, because you're going to see this until somebody finally takes consideration of it, which could be forever. But it's electron flood theory. Everything is dipoles. Electrons are dipoles. The nucleus is made up of a batch of electrons per proton. 1,839 electrons in a ball make up a proton. Similar to a situation like this, instead of a proton looking like that. And they know that they can smash them into tiny little bits. It's not a mystery anymore. The mystery is, how small can they make them? What is the smallest elementary particle? And I believe I've shown it, and I believe that's it right there. When it breaks apart here, the smallest elementary particle is the black and the white showers, and those are white balls. And as far as that, I can't see it getting any smaller, although we did see something that was very strange and did not fit into anything that I've seen so far, but only one of them. Higgs fields, we got them just scads of them coming out of our ears, but they always look the same. These are round little discs with all these little circles and bumps on them. Then we had this one here show up, and that one, I believe, ended up being this particle here. Hold on, where is it? Right there. And that I don't know, I have no explanation for this whatsoever. That is like in the midst of being a Higgs field and an anti-Higgs field, it looks like to me, and they are converging into a, I don't know what it is. We're just going to dig through this. Now, I would expect the powers that be, CERN and Fermilab and everything, what I'm showing you is exactly what they're looking for, and they will refuse to engage. What does that tell you about the scientific mind? It tells me it's a disaster.